Hello, my name is Sam. I'm an online maths tutor, and this is the second episode in a series of episodes all about quadratics. Now, in the last episode, we had a look at factorising quadratics and some basic quadratics, and today we're going to look at solving them and what that actually means. So, here we have a quadratic x squared plus 4x minus 5, and the question is solve for x. And I've also written down factorising there, as this is going to be important. So today we're only going to look at factorisation as a method. In future episodes I will cover other methods such as completing the square and the quadratic formula. But for now we are just going to look at factorising. So let's lay out our question. X squared plus 4x minus 5 equals 0. This is what the question will look like in the exam. It may say solve for x and it may just say solve. So what does it mean? Well, we want x to equal something. We want an answer to this equation. If it was just x minus 5 equals 0, we could easily gain x equals 5. But unfortunately, that is not the case here, as we have a quadratic. So what are we going to do? Well, the first method that we can use, which is the method we're going to look at in this video, is factorising. So let's factorise this expression, x squared plus 4x minus 5 equals 0. So it's an equation. So to factorise this, the coefficient is 1, so we don't need to worry about that. We're looking for two numbers that add to make 4 and multiply to make 5. I wonder what two numbers those are. So I'll give you a second. But those are 5 and minus 1. So x plus 5 times by x minus 1 will equal 0. And that is the factorisation for this quadratic. As when you expand this, you are left with this expression in the end. But what does it actually mean for this to be equal to 0? Well, I've got a graph over here of the same equation. Now this time I have graphed it. So this is y is equal to x squared plus 4x minus 5. So we are saying our y coordinate on this graph at any point is equal to this equation. So given a value of x, if x is 1, then we have 1 squared plus 4 minus 5 is 0. So if x is 1, then you can see here the y value is 0. That is how this graph works. So what does it mean then if this equation is equal to 0? Well, we're looking for where y is equal to 0. And y is equal to 0 on this graph on the x-axis. This line on the x-axis is exactly where y is equal to 0. If, say, this equation were equal to 5, you could draw a line at 5 and do the same thing. Although in that case, we would probably want to move the 5 over to the other side and compute it equal to 0. So now that we know that, we are looking for where this equation, or at least the graph, in this case the red line, for this equation crosses the x-axis. And that's what's known as the roots of an equation. So using the factorising that we just did, we have x plus 5 and x minus 1, and that's going to be equal to 0. Now what do we need in order for this to be equal to 0? Well, we've got one thing multiplied by another thing. In order for this to be equal to 0, either this half is equal to 0 or this half is equal to 0, which means we either have x plus 5 is equal to 0 or x minus 1 is equal to 0. If we subtract 5 from both sides of the top equation, we have x equals minus 5, and on the bottom we can add 1, so we get x equals 1. And these are our two answers. That's a terrible circle. These are our two answers. X is equal to minus 5, x is equal to 1. Now what does this actually mean? Well, these are the two x values on this equation where our y value is equal to 0. So if we go back to the graph here, x is minus 5 and x is 1 indeed is the location where this line crosses the x-axis and is subsequently where y equals 0. So let's have a look at another example. So this example is x squared minus 3x minus 18 equals 0. I don't have the graph for this one, but again we're going to be looking for where the equation y equals x squared minus 3x minus 18 crosses the x-axis. If you're given a graph in your exam and it tells you to find the roots or the solutions to an equation, say an expression like this, it is asking for those points where it crosses the x-axis. So let's solve this equation equal to 0. So x squared minus 3x minus 18, we're looking for two numbers that add to make minus 3 and multiply to get minus 18. Now to solve this we can look at the factors of 18. So we have 18 and 1 definitely don't add to get minus 3. We have 9 and 2, which in no combination can add to make minus 3. And we have 6 times 3. 6 times 3 is 18, and minus 6 plus 3 is minus 3. So we are going to have a minus 6 and a positive 3 in here to be the factorisation of this expression. And now if this is equal to 0, either x minus 6 is equal to 0 or x plus 3 is going to be equal to 0. This means that x is 6 and x is minus 3, and these are our answers. Okay, perfect. We will try one more. This is a slightly harder example as it has a 2 as the coefficient of x squared. Coefficient just means the number that comes before the x squared term. It follows the same that 13 is the coefficient of x, and 15 is not a coefficient of anything as there's no value here. So because of this 2, we need to treat this a little bit differently. So we are still looking for two numbers that add to make 13, but this time they're going to multiply to get 2 times 15. So two numbers that add to make 13 and multiply to get 2 times 15, which is 30. I think it's pretty simple to see those two numbers. It's going to be 10 and 3. Now we are not going to put this straight into the brackets that we want to. We need to solve this. I go through this process in my last video if you want to take a look. So we're going to have 2x squared, and then you can put these either way around you want. So we have 10 and 3. You could have the 3 come next or the 10 come next, but I'm going to do the 10 as 2 as a factor of 10. I will then add 3x, add the 15. So I haven't changed this expression at all. I've simply just turned the 13 into a 10 plus a 3. And then going to split this down the middle and pull in 2x out of both of these terms to have x plus 5. I can then pull a 3 out of both of these terms, x plus 5, and then I will factorise the x plus 5 out of here. So if I pull the x plus 5 out of here, then I'm left with a 2 and a positive 2x and a positive 3. So this expression factorises into x plus 5 times by 2x plus 3, and this is again equal to 0. Now to solve this, either x plus 5 is equal to 0 or 2x plus 3 is equal to 0. Remember, this is since that this bracket times this bracket must be equal to 0, so one of them must be equal to 0. X plus 5 we can do quite nicely. We will just subtract 5 from both sides to get x is minus 5, and in 2x plus 3 we can turn it to 2x equals minus 3 and then divide both sides by 2, giving us x equals minus 3 over 2. Perfect. And then the graph of this, so if you were to graph y equals 2x squared plus 13x plus 15, the graph would cross the x-axis, or this equation would be equal to 0, where y is equal to 0, at these two coordinates. X is minus 5 and x is minus 3 over 2. Thank you for watching.